Okay, for today, we're going to be just some facts you should know. A lot of ways to make a 64. 8 squared, 4 to the third, 2 to the sixth, those are all 64. Why? This is like out of the blue. What the heck does that have to do with anything? I'll tell you in a second. 81 is also a couple important things. It's 9 squared and it's 3 to the fourth. Those are both 81. Okay, well, do you have a short-term memory? Let's see if you remember that when the critical moment comes. All right, so here's what we're doing today. If I said 2 to the x equals 8, would you agree it'll be even easier to answer if I said 2 to the third, because that's what 8 is. If you don't see what I'm talking about, you maybe didn't even think about what the answer was. The answer was 3, and look, 2 to the x is equal to 2 to the third. Makes it really obvious that if the bases are the same, then those just have to be the same. So do you get it'd be pretty cool if you could take any problems like this and just make the base the same? Because then the answer will just be the exponents are equal. Let me give you a more complicated one. 2 to the 3x is equal to 8. Well, that, if I was started with that, that would have blown a lot of people's minds. But I bet you're going to know to replace the 8 with what? 2 to the third. And then 3x has to equal 3, so x equals 1. That's really what today is like, but just more and more complicated exponents. All right, I can give you another one that's just a little more weird. 2 to the x minus 1 is equal to 4. I want you to replace the 4 with something.
What?
I want you to replace the 4 with something. What do you think I want you to replace the 4 with? Yes?
2 squared.
2 squared, exactly. That way, that has to equal that. Now, I made it easy enough that you could do it in your head, but do you get if this was complicated? You could go, x minus 1 needs to equal 2, and then you could solve it from there. Now, this one, again, I know I made it pretty easy. The answer is x equals 3. But if I had made this like 3x minus 11, you could have just said 3x minus 11 equals 2, and it wouldn't have been that hard. All right, so here's, get harder, of course. These are the ones we expect you to know. Like the 7's all the way up to 49. The 8's all the way up to 64. The 9's go up to 81. And 5 to the third is 125. You see what's going on here? And you'll be expected to know that 4 to the third is 64. Now, why am I saying you expected to know these? Can't you just use the calculator? No, we're not using the calculator on this unit. You just have to memorize like 4 to the third is 64. And if you don't know it, you can multiply it out by hand. Most people know 4 times 4 is 16, and then you just got to do the last part, by hand. I personally would do it this way. And then 6 and 4 is 28. 1, 4, 5, 6, 68. Perfect, right? 24. There, 64. But if you just have it memorized, it'll be better. And again, a lot of people don't have this one memorized. That's why we're talking about it right now. 3 to the fourth is 81. Let me show you where it would come in. If you're like able to go, oh, 81, that's 3 to the fourth. Then you can replace this with 3 to the fourth, and then you can be like, oh, clearly this is correct. Powers are the same.
Yeah, because 3 times 3 is 9.
Yep, 3 times 3 times 3 times 3 is really like 9 times 9, which is really like 81. It all works. Okay, let's go to the next page. So how about this one? Well, if you can't solve this, I don't know if there's too much hope for you. Solve number 1. X equals 8. Raise your hand if you had 8. Okay, good. The next one, well, that's a little harder because I thought we wanted the base to be the same, and it's 9 squared, and then what the heck? Well, then you can go like this. 3 to the x equals 9 is really 3 squared, right? Then do I just ignore the other squared? No. 3 squared squared. See what I did there? I replaced this 9 with this 3 squared. And then that's really like 3 to the 4th. If you wanted, you could have made 9 squared into 81, and then you could have been like smart enough to go, oh, that's just 3 to the 4th. 3 to the x is equal to 3 to the 4th. But here's the theme for the day. Once you make the bases the same, it's easy. Just make the exponents, set the exponents equal. On to the next page. Make the bases the same, and some of these get tricky on making the bases the same. Tate, do I have to throw things at you? Good. Number 3, find it. I'm not going to do it until you wake up. Sorry, there's 2 chases. Or no, there's a tape in the chase. Sorry, I got confused there. We're going back into the back corner. Albright. 8 is really the same as, wait a minute, you can't make that 4 to the something. What do you do?
Isn't it half, 1/2?
4 to the 1/2 would be the square root of 8. Good guess, but no, I don't think you mean the square root of 8, because square root of 8 is not 4.
Oh, yeah.
That was a thought, but what do you think?
Like 2 to the 3rd.
All right, 2 to the 3rd. But what about the x?
3x.
Exactly. And then we can make the 4 into 2 to the something, and then it's not that bad because the bases are the same. That equals that. 3x equals 2. And I know you can't do it in your head super easy, but you just divide by 3, and the answer is 2/3. So we made them both have the same base, but neither one of them had a base of 2, and you had to be smart enough to realize, oh, I could make both of those be 2 to a power. Same idea here. You're not going to make this into a base of 1/4. You're not going to make this into a base of 32, but they could both be a different base of 2. What if I tell you that? 2 to the something and 2 to the something. And don't forget the x. 2 to the what? You can figure it out. 2 to the what? It takes a little bit of knowledge of like how to flip things, because this is 1/4. Don't forget the flip thing is a negative exponent. If I give you just that hint that there's a negative exponent involved, maybe that's enough for some of you. This might just be a memorized thing. Who knows that 2 to the 5th was 32? Raise your hand if you had that one right. Cool. That's just a memorized thing. The other one, that's more of a knowledge, like you understand negative exponents. I did hint it was negative, so you could have known, well, negative something. And then I want the 2 to turn into a 4, kind of. Is that good enough? It is. Because 2 squared is 4, and this flips it. Now the bases are the same, so that equals that. Basic algebra after that. So 5x has to equal -2. Again, don't try to do them in your head, just write it out. 5x has to equal -2. And then from there, your instincts will kick in. Divide by 5, no big deal. Do you get? This is all about making the bases the same. And then the difficulty level of making the bases the same increases. But after you get the bases the same, you just got to set these equal. It'll be so easy. So the only hard part will be, what if the bases are weird, like these? You can't make this into 9 to a power. A lot of people think 9 to the what is 27. I can't do it. You can't make it have a base of 9. But you could make it have a base of 3. And yes, there'll be a negative power involved with this problem. And don't forget the x. Both of these need to be 3 to a power. Both of these need to be 2 to a power over here. See if you can do 5 and 6. And some people are probably already done because you just get that good at it. Other people have barely started, so give them time. Ask them, are you ready yet? Before you share your answers. Don't just be like, did you get 6 and 5? Wait till they're done. So Anna, can you tell me on this problem 5, you changed them both to have a base of 3. What's that first one? 3 to the what? 3 to the third is 9? Oh, maybe you did this one first.
Oh yeah, I did 27 first.
Okay. And then this other 3?
I did 3 to the negative 2x.
-2 is correct. And now you set the powers equal. And then what'd you get for a final answer?
X equals negative 3 halves.
You are correct. All right. And the other one, this is row 5. Jack Metner, that's you. These both have a base of what?
2.
And then you made that one into 2 to the what?
Negative 2x.
-2? X. Oh, okay. So you're really saying this was just 2 to the -1.
Yeah.
That, in case anybody missed that. That 2 was 2 to the -1. That's what makes the half. Okay, then over here, 4, I got to make that into 2 also. Can you do that one, Jack? -2. The negative makes it the flipped into 1 over, and 2 squared is 4. Perfect. And now -2x is equal to -2. Divide both sides by -2, and x equals 1. Who had that one right? Cool. So then after, they just get into more square rooting. So let's talk about how square roots work again. I'm going to go off to the side. If I said I wanted to make 25 into, would you agree that 25 could be thought of as 5 squared? Do you get what I'm doing so far? 25 is like 5 squared, right? But couldn't I have put 25 to the 1/2 power and made that be 5? Is this a true statement? Do you remember that means square root of? Remember that? Okay, that's important. It's going to come in handy in a second here. All right, on this one, that and that could have the same base if I really thought about it. And the base will need to be a fraction. For the first time, the only way to do this is to have your base, it's not going to be a whole number like 5. It's going to be a fraction. Do you get that that both of these could be based on a 5/2? Think about that. This one already is 5/2, so we don't have to mess with it, but this one could be a fraction base of 5/2 to a power. And then don't forget to bring the 3 down. So what's the power? Like I said, from here, it's only going to be that the fractions are going to get, that the bases are going to get harder and harder to figure out. What did you think, Catherine?
Negative 1/2.
Negative makes it flip. Yup. And the 2 part of that makes it squared. But wait, did you say -1/2? Because what -1/2 would do would be to square root them. Try it again.
It would be -2.
-2 is correct. You were really close. Because we needed these to get squared so that they would be bigger numbers. And we needed it to flip. That's squaring, that's flipping. So after you've made the bases the same, then it's just that equals that. And so it's easy, x equals -6. Because -2 times 3 makes -6. All right, on to this page. If you get this, I think we're good. Take a second, figure out what bases these could both be. And once you got the bases the same, it's easy. I'll pause. Okay, did you figure out that the base we were going for was a 2? I think this was easy enough that you could have caught that. Then you had to remember to bring down this little x minus 1. Then you had to remember that this really isn't 2. It's 2 to a power. 2 to the negative 1 makes 1/2. And 2 to the third makes 8. And now that you've got that set up, if you could handle this problem, you can handle almost anything, because this is about as hard as they get. Do you get that, how I've set it up so far? Does this make sense so far? I just replaced 1/2 with 2 to the negative 1, and I replaced 8 with 2 to the third. And like I said before, if the the bases are the same, you just got to set the powers equal. That negative 1, should I just pick one of them and randomly stick a negative on it? Of course not. I need to distribute it to both of them. You get I can't just stick the negative on whichever one I feel like. I have to stick the negative on both of them. Another way to say it is it's like negative 1 parentheses x minus 1, which when you multiply it out, gives you negative x plus 1. X equals negative 2. Who had negative 2 before I said it? Not many, and that was hard. I said if we could all get this one right, then you were totally ready. Well, I get this was hard. Let's do one more like that. Now that you saw me do the last one, maybe you can do this one. And again, I know a few of you have conquered it without my help last time. This is one of those kind where you got to use a fraction base. I'll pause for a sec while you give this a try. Okay, I hope you realize we were going for 3/7 as the base. So this one's already good. How do you know that? Well, because I know that the square root of 49 is 7 and the square root of 9 is 3. So I know that there's a 3 and a 7 in there somewhere. I need to know, honestly, right this second, how many of you have already got this problem done? You figured it out. All right, that's about half of you. For the other half, let me show you. I know it has to be a 3/7. Like, look, they have to match, right? So write the 3/7, and then don't forget the x, and then the only thing you're left with is what to put here. What do I put there? Well, I gotta make it flip, so it had to be negative, and I want my big numbers to get smaller. So it's not just negative, it's negative 1/2. Raise your hand if you pulled that off. Okay. Maybe some of you need a little more work on your fraction powers. I get it, they're weird. Yes?
Me too.
Uh-oh, hold on. Hold on. Dang it, I went backwards in my head. My big numbers do need to become smaller, and that's what I was thinking. But if I'm going to take my small numbers that are 3/7 and make them get to be big numbers, you are right. That has to be squared. As much as I hate to admit it, I can't fake that you're wrong. You are absolutely right. So in my head, that made total sense that I needed to use the square root because I wanted to go from 49 down to 7. But really what's happening is I got to make this number into this number, so I need to square it, and it's got to flip negative 2. Sorry about that. Good catch. And last but not least, negative 2x needs to equal 3/2. You get where I got that? And then we'll just have to clear this negative 2. I personally like to clear the fraction. Do you remember me saying clear the fractions a bunch of times? I'm timesing both sides by 2. You don't have to do it this way, but in my opinion, it's the easy way. Because then there's only one last step. Negative 3/4. Who had negative 3/4? Yay. Jane's question. Comment.
Multiply by 2 and negative 2 is being multiplied by 2. Shouldn't you divide by negative 2?
Yes, but if you divide by negative 2, you'll have a fraction that you have to divide by a negative 2. Do you get how that'll be a pain in the butt?
Yeah.
So my way of doing it avoided having to take a fraction divided by a number. So you weren't wrong, but your final answer would have to come out to negative 3/4. So here's essentially what she's saying. Let me help you guys understand what she's asking. She's saying, don't you have to get rid of this -2? That's true. But if I'm going to divide both sides by -2, I have a fraction divided by a fraction, which is kind of a pain. And you're not wrong, this will work, but you got to deal with that. So I think it's better to times both sides by 2, which is legal. You would agree with that, right? And the reason I think it's better is that just cleans it up, and all of a sudden, I don't have fractions anymore. And I had this, and anybody can look at that and divide by -4 and have the answer. A lot of people will look at this and never know how to do it. But if I change this from divide by -2 to multiply by -1/2, you'll still get -3/4. So your way wasn't wrong. I'm just trying to show you what I think is a better way, which is clear the fractions out. Yes? In a second. All right, we're almost done. So we're going to do number 10. It looks really complicated, but go back to what we're doing every single time. Make the bases the same. Tate, 16 can be made into what? 2 to the 4th. And once the bases are the same, then that just has to equal that. Nobody said I'd have to remember how to do quadratics. Do you get that that's, if you can factor it, you should? You remember that old saying? Get it moved over so that it's equal to 0, and then you'll be able to factor it, and then you'll be able to get your answers. Math is one of those things where we keep coming back to the stuff we learned before. It's not like history class where you may have learned something about the Civil War, and then you talk about World War II, and then the Civil War doesn't matter at all. I know. I'm sure you could find some way it matters. But my point, I need you to remember things like how to solve a quadratic. You can't just like set that unit aside. And the reason I say if you can factor it, you should, is because it happens so often. I always get the signs next. I think, what would make a -4? Oh yeah, it has to be a plus and a minus. Has to be. And then I can think about the 4 and, oh yeah, 4 and a 1 is probably going to work. 4, 1, x equals -1, x equals 4. Who had that before I said it? Cool. Right, and now, there is a Schoology quiz called Change of Base. And if I haven't already put it in there, I'm going to, so hold on. Is it there?
Wouldn't it be,
Excellent. Oh, question?
Wouldn't it be -4 and 1 instead of -1 and 4?
So, what were the factors? Can you tell me that? Because I don't want to go to the last slide or it'll mess up my video.
Yeah, that's what I'm saying.
I think I had an x minus 4 and an x plus 1. Is that correct?
Yeah.
Okay.
I thought you said -1.
And yeah, I'm pretty sure that that's what I said. I think I had it backwards. I think I had the x plus 1 here.
Yeah.
Okay. I think it was like that. And so then my two answers are x equals 4 and x equals -1. Okay, that's all I got for you for today.